Welcome. Good afternoon, everybody. I'm Yeet. I'm the technical lead for architecture components, and I'm here joining with Kirill. He's also part of the team. So today we are going to talk about persistence. Now, this is a loading screen. This is one of my favorite screens. Said no one. No one ever said, I like to wait. Especially if there's some content that they have already seen, and if you're making the user wait to see the same content, it's horrible. Like, you're a bad person. I didn't mean it. So, now how do we fix this? We persist the data. This is what we recommend developers. Whatever information you fetch from your network, different data sources, save it to disk so that if your application is restarted when there is no network conditions, you can show something to the user. You can make that experience seamless. When we say persist on Android, we know this is a very crowded field. There's a lot of different options, different companies, and most of these solutions are really, really good solutions. But especially if you come to Android and if you're new to the platform, what you would do? You would check what is inside the framework already. So there's these three things that come with the standard library. And if you read about them, you realize that if you want to put structured data, then you want to go with SQLite. SQLite is something we have been shipping since Android 1. It's a proven technology, works very well. So you go ahead and say, OK, I know SQL. I want to use SQLite. You go to this page. This is the very first page you see. This is horrible. This is like, it's kind of trying to say, you know what? You actually don't want to persist. That's not what we meant, but this is what we have. So we said, you know what? Let's look at this page. Like, we want to make this better, right? Let's look at this page. It's trying to say, I want to select these columns with this constraint, with this order. So if you look at this, this is a very, very simple SQL query. But it takes a lot of stuff to write it. You even need to define all these constants which are not even visible on this page. So I want to say, OK, there's some room for improvement. And I came up with Room, which is an object mapping library for SQLite. Now, OK, we said, OK, let's step back. We said writing the same thing with SQL is a lot shorter, a lot nicer. So let's go back to our roots, which now there's an SQL query that we assign it to a string. It is standard SQLite. Now, of course, if it is like this, we cannot understand it. We love annotations, so we put it inside an annotation. And if it is inside the annotation, now you want to get the response from the query. Want to say, well, put it into a method so we can understand what the query wants to return. Now, we know that this is a query. It wants to fetch these columns from this table and with this constraint. But if you look at the constraint, there's actually a bind parameter. This is SQLite standard bind parameter syntax. We didn't come up with this. So where do we get this bind parameter? How do you get parameters to your functions? From the function arguments. So we put it there, the most obvious place to get this argument from. And then last but not least, we want to know what it wants to return. OK, so it's returning list of weeds. Now, of course, there's that feed class, so it needs to be somewhere. We have that class. And I want to put this query inside a data access object. That's what DAO stands for. Because you don't want to have your application making database queries around the code base. You want to put these into certain classes, which we call data access objects. So if it's a DAO, we need to tell Room that this is a DAO. And then we need to tell Room that feed is some class that it would like to persist into a database. Last but not least, we need the database to put these two things together. That needs to extend the Room database class. And so the feed DAO we define there. We just say this database has this DAO. And the feed entity we define there, we put inside database. So you can have multiple entities, multiple DAOs. You can actually have multiple database definitions that access the same DAOs. As long as whatever schema you define in that database works with the DAOs and entities, Room will figure it out. Once you have all that description, you can get the implementation of that database through this builder. It's very similar to how you use Retrofit Dagger. You define the interfaces, we provide the implementation. Now, of course, because we are doing the implementation, select queries are very specific. We really don't know how you will select. But there are other queries, right? You would like to insert something into database. So we said, OK, we can just define another annotation to make it easy for you. Inside these annotations, these are actually very, very flexible. You can say, you can pass multiple arguments. Like if you read this method, it says insert both. You really want to insert both of them to database, and Room understands this. You can send a list of items. You can send variable arguments, multiple parameters. Like if it is readable, Room will make it work. You can even say, like, if when you try to insert this thing, if there's a unique key conflict in the database, do this. So you can also specify these constraints. So since we have the insert annotation, we have similarly delete or update annotations just for the very common tasks. Now there is, so we said we just start support.SQLite, but there are some cases where writing SQLite is harder. For example, I have this query where I want to query these feeds, but I'm trying to return a list of feed, which means like I want to get multiple feed items, right? So that means I want to get them by ID, so I probably want to pass multiple IDs. Now in SQL, you will do this in these IDs, but you need to know how many IDs you have so you can put that number of bind parameters. But this is some information we don't know while writing this query, right? Well, that's OK. Room can understand it. If whatever the parameter you are passing to your function is a collection, Room knows that, OK, they want to have multiple bind parameters. At runtime, we will generate the right query for you, and we will do that. You can send them as an array, send them as a list, doesn't really matter. If Room can understand it, we will do it for you. Now, the most important part about Room is that once we let you define all these things, then actually Room understands these queries. It's not just take this SQL and then like compile time generate the code. Room understands it, knows what you are trying to do, and this gives us a lot of power. For example, if Room looks at this query, it says, OK, this is a select query with this bind parameter, which is passed in as a string. And it knows it is from the feed table. And it wants to return items as feeds. Then Room goes and says, OK, can I validate this? Yeah. The table has these 3 columns. The feed item has these 3 columns. These match. They're fine. You could have another class instead of that feed that has these 3 fields. Room will still work. Now, after this verification, let's say you made a typo, right? Like the reason why we define all those constants or use Java builders is all to avoid these mistyping queries. Room can do this validation for you, similar to Java code, right? You don't use builders to write Java code. You write your Java code, compilers tells you if it is wrong. And the IDE helps you with this. So the reason why we don't have builders is that we think helping you write SQL query is the job of Android Studio, which they are working on it. But once you write the query, Room verifies that it is correct. So if you do this mistake, Room will not let you compile the application. Similarly, if you access some columns that doesn't exist in the database, again, it will be a compile time error. By the way, it can be any query. You might be joining 5 tables. Room will still understand. You may have grouping, like almost anything in SQL. Let's say we made a mistake like that, where we only fetch the subtitle column, but we want to return this as a feed. Now, in this case, the feed object also has a subtitle column. So this might be intentional. Maybe you are going to fill in those fields later on, or you made a mistake. We don't know. In this case, Room just generates a warning. It says, hey, feed class has these 2 other fields that you are not returning from the query. It will just give you all the details, well, what the query returns, maybe you made a typo, and what are the fields in the column, in the entity. Now, there are 2 ways you can get rid of this warning. The first thing you can do is, maybe you really want to return them as feed instances, then you can tell Room to ignore it. I know what I'm doing, suppress this warning. Alternatively, you can just create any class. As I said, you can just say, return me these as a string, right? You are returning 1 column is a string, and Room will do it for you. Very similarly, what if we are returning ID and title? In that case, again, Room will say, well, there's 2 columns, 1 string that doesn't match. It will give you an error. when that happens, we can just create a POJO. Again, any class in your application, as long as we can read what's inside it and it matches what the query returns, we will generate the code. And to make the match, you can rename the columns in SQLite. All of those things works here. Now, this room does everything automatically, but there's sometimes you have classes we don't know about. And I want to invite Kirill to talk about them. How do we extend room, Kirill?
Right. Thank you. So let's talk about something a little bit more interesting. Going back to this feed object that has one ID, integer field, and 2 strings, these are primitive types that are directly supported by the underlying SQLite database. What happens if we want to add a field of a type that is not directly supported by SQLite, such as Java util date? In this case, at compile time, Room is going to tell us, well, I can't really figure out how to save this. You need to help me out. And the way you help out in this case is provide 2 methods to take your original data, convert it to something that SQLite can store. So that is going into the database. And on the way out, when you're doing the queries, convert back from that representation in the database to your original data type. You implement these 2 methods. In this particular case, we are converting date to long and back from long to date. We annotate them. As Yit said, we love annotations. We use the type converter annotations on these 2 methods. And then we take this myConverters class and use the type converters annotation pointing to these 2 methods, pointing essentially to this class that has our converter methods. You can put it directly on the field in your entity object. You can put it on the entity object itself. You can put it onto your data access object class or the specific query in it. Or you can put it on your database class. No matter where you put it, at compile time and at runtime, Room will do the right thing to find those 2 methods. Now with this, we can write a query that finds the list of all the feeds that were posted between 2 specific dates, from and to. So here, since we are accessing the from and to fields or columns in the database that are defined as long when the database table is created, you don't really want to use long as the implementation detail. Since you are using the date class for your entity data field, you want to use the date objects in the query itself. And this is what you do here. And when the query runs, these 2 values, from and to, are going to be converted to longs. The query will run. And on the way back, when Room constructs and fills these feed objects, it's going to convert back from long to dates. Now let's talk about even more complicated stuff. What happens if you have a class hierarchy in your kind of data model universe that has object graph that is not flat? In this case, we are adding a location object that has 2 double fields, latitude, longitude, into our feed. Now what happens at compile time? Once again, at compile time, you need to tell Room how to store this field, since especially here, it's not a primitive type, but it's a type that has subfields in it. So one option is going back to our type adapters. You can do something like take latitude and longitude and convert them into a single concatenated string with some kind of, let's say, semicolon as a separator on the way in. And on the way back, it's going to be some kind of a split where the string goes back to these 2 doubles. Or you can go to do something like bit masking and bit shifting to try and convert these 2 doubles, encode them in one long field. This is going to be hard to query even for this simple case when we only have 2 doubles that we are trying to encode. We're trying to kind of compact it into one field. And the more complicated the data structure is, the harder it becomes to use type adapters for these cases. Another option is to say that I'm going to flatten everything, that you are going to flatten everything for us. So instead of having the location data field in your data entity, you are essentially flattening all the fields from the location class into the main feed class. And then Room is going to create these 2 latitude, longitude columns, which works, but first of all, you lose the encapsulation. Now you just look at the definition of your data class, of this feed object, or somebody else in your project looks at that, and it's not really clear that these 2 objects kind of represent one single entity. And another thing is, just because you want to persist this object and later on retrieve it, why should you be changing the definition of your data classes? That's not good. Instead, there's another option, which is also not ideal. You can say we have two data classes. Why don't we store these objects, each one in its own separate database table? So we have our feed object with ID, title, subtitle, and posted at, the date. And then we have the location, latitude, longitude. Now, in order to connect them, not when you save, but when you retrieve them, in order to connect the location back to its feed, you need to have the primary key, the feed ID, so that they are combined together. Once again, it works. First of all, yet another table is not very clean. But also, going back to what I mentioned before, why should you be forced to change and tweak the definition of your data model classes just because you want to persist them? So what would be ideal is that you have your clean separation of how you define your data classes, but at runtime, the way the feed object is persisted is in one flattened table. So essentially, the latitude and longitude fields from the location are flattened into the same table. And the way you do it is with this embedded annotation. At compile time and at runtime, Room is going to figure out how to flatten your entire hierarchy into this one table. Now you can write a query like this in your data access object. We are going to select all the feeds in the specific geographical rectangular area. As you can see, we are referencing latitude and longitude in the query directly. They are not in a separate table. And you are just using the same names for the database columns as the attributes in your location object. You can write a query like this to select the location for the specific feed based on the feed ID. And Room is going to figure out that while it needs to fetch the entire row from the database, it only needs to create and fill the location object, because this is what this method wants to return. Or if you want to be more specific, you can say, I only want you to fetch the latitude and longitude from that table. The last part about embedded objects is what happens when you have more than one field of the same kind of nested class. So in this case, we want to store two locations. So what is going to happen at compile time, Room is going to say, as I was flattening these fields into one database table definition, I see that the same latitude field is defined by two objects. And since SQLite doesn't support having two columns with the same name in the same database table, it's going to fail as an error, not as a warning. And what you need to do is, in case you do want to have something like this, to have, in this particular case, two locations, you want to use the prefix attribute on the embedded annotation. At compile time and at runtime, it's going to be used as Room is flattening the data graph definition. It's going to use this prefix to create latitude, longitude for the original, for the first location, and sin latitude, sin longitude for the second location object. Now let's talk about observability for those of you who have listened to yesterday's introduction session and who have been here at earlier in the day to listen to the lifecycle live data view model. We want to talk about observability. So this is a simple query that returns a list of feeds based on particular query. This is kind of a snapshot, a point in time where you have run this query, and however many feeds it returns, it represents the state of your data universe at that particular moment. What happens if your data is dynamic? It can be manipulated directly by your users in the app, or maybe it's pushed or pulled from the server. So in this case, if one of the feed changes in the database, when you add new feeds, when you delete existing feeds that match this query, every single time to reflect these changes back onto the screen, you would need to refresh this query explicitly, to run this query again and again. Instead of returning list of feeds, you can wrap this return object. It can be a single feed or a list of feeds in a live data object. This instructs Room not only to fetch it once, but also update the live data, the callback that you pass to the live data when you call the .observe, we'll see it in a few slides, every single time any one of the objects that were returned by this query was changed, or new objects were added, or existing objects were removed from the result of the query. And this is my favorite part by far of architecture components. And also, we provide support for using Flowable from RxJava too. So let's see. Like this one. OK, so let's see an example of how Room integrates with the rest of lifecycle-aware and lifecycle-aware parts of architecture components. We're going to start with a simple database interface. It has one method to load the data for a specific user, and one method to save the data. The first time, it's going to be a simple insert. And then, as the data changes, it's going to be an update or replace. As you can see here, instead of returning the user object directly in our load method, we are returning a live data that traps the information about this user. Now, we're going to set up the data binding to actually show the information on that user, perhaps in the details page or somewhere in some kind of a profile page. We have our lifecycle activity. It can be a lifecycle fragment. It can be a lifecycle service, or your custom lifecycle owner. In this case, we're using a lifecycle activity. And in onCreate, we're going to get access to our database and database access object. We're going to call our load method that returns the live data that traps that user data. And now we are going to use the observe method on this live data object, passing two parameters. The first parameter is the reference to the lifecycle owner. This is our activity. And the second parameter is the callback that is going to be invoked by Room at runtime every time this user information changes in the database, on the first load or on the subsequent updates. Now, word of caution, because it's kind of like, we don't want to put too many lines of code here on one slide, you usually don't want to kind of expose database details or details about loading this information from your web service or caching it locally in some form directly to the activity or directly to the fragment. So this code is highly recommended to be put in a view model. And once again, the most powerful part here is this connection between the lifecycle activity, the owner that says, I'm active or I'm not active, and the live data that Room returns as a result for this particular query. This callback, the callback that you provide as the second parameter to the method, once again is going to be invoked every time Room detects that the result of that query that you wrote, select star from the user database table, has changed. Once again, the flow of information is one part of your app. It can be some kind of a service that pulls information from your backend, or maybe the information is pushed through some kind of network tickles. It gets updates on the data. It's using this save method to insert the information into the database or update the existing information. As the data is updated in the database, Room is going to detect at runtime all those active places in your app, activity, fragment, service, or your custom lifecycle owners that are active and that are subscribed or are observing a live data object that traps the information that has been updated. And then this callback is going to be invoked, letting you know that most probably you want to update whatever slice of data is right now showing in the application screen. So for example, it can be an app that shows live results for some sports games, or live updates for weather wherever you happen to be, or live updates to market stock prices. One part of your app handles the data flow, get that information, and display and insert it into the database or update in the database. And the other part gets notified by Room and the live data that the information is now has new data. And you need to update whatever the presentation is, once again, in your activity, in your fragment, or in your service that posts maybe notification or handles a widget.
All right, thank you. So let's focus on another important topic, which is relations. Now, SQLite is a relational database, so it can understand the relations between entities. And if you are using any ORM on Android or like in any other platform, they usually try to handle these relations for you. So let's look at it how it works in Room. So if we have a feed, we probably also has a user object which has posted this feed item. So you want to have a user field inside that field, inside that entity. If you do this in Room, it actually won't compile the application. The moral of the story, we don't allow entities to contain other entities. Now you're probably asking why everybody else does this, and if we can understand all this SQLite, why can't we just enable this? Now there's a very particular reason for us not to do this. We have seen a lot of problems with applications caused by this kind of models. So I just want to go through an example. So first, let's look at this query. It tries to select a feed with some ID. When we select this feed, or when you look at this feed item, you cannot know whether it also fetches the user or not. It's very hard to define. And most of the ORMs, the way they solve this problem is you just say lazy loading, right? Until the user wants to fetch that data, don't load it, which works very well if you're working on the server side. But on the UI, it is a little bit more tricky. So let's implement that lazy loading, right? We could just generate this code for you. We could say, like, just keep a user ID, also keep a user instance. When the get user is called, we could say if the user is the first time, now fetch it from the database. Otherwise, just return the existing row. Well, it's very easy. We believe this is actually a mine planted in your code base. Let's see how we exploit it. We are using a recycler view where we show these feed items, and then we'll get the feed and we'll show the title and the subtitle of the feed item, which all looks fine. And then like 2 months later, your product manager comes, actually, you know what? Let's show the username in that feed item as well, right? It makes sense. It's like, okay, it's so easy. Your developer goes, just adds, well, feed, get user, get username, put it on the text view. You are done. You send the code review. It looks obvious. It passes the code review. You test it, it looks fine as well. But when your users start using it, and then your application starts receiving these ANRs, which stands for application not responding. This happens because when you are testing the application, you're on device, there's good network, everything is fast. But when the user is using their application, there's this probably like 50 other applications that are also trying to run. And if you want to relate to this, just try to use your application when Play Store is updating your applications. You will see how it feels. I mean, these are still mobile devices. The disk on these devices is like actually relatively slower. So, and the UI thread only has 60 milliseconds. So even if your query takes 5 milliseconds, like ignore all the locks and everything. Even if it's 5 milliseconds is a lot of time. You can probably like lay out 20 recycler views at that time. So how do we solve this problem with Room? Now, previously we said SQLite is a relational database, right? We should just take advantage of it. We just keep the user ID. We know the feed is a user ID, just keep it. And now we can write a query that says, I want title, subtitle, and username, and join me these two tables on this constraint. Like, this is already a solved problem on the SQLite land. Why don't we just embrace it? When you do this, it's faster. You only fetch the data you need. And when you fetch the data, you know that data is in memory. I was saying, wait, what is this item? This is it can be like any Java class. It may even have a constructor with public fields, public final fields. Room will set this without any reflection. We will use that constructor. You can even say return a live data because Room knows about the query. It knows it's querying these two tables. Like, think about the other example. If you were observing the feed, if the user changes, how do we know should we invalidate the feed or not? But when you wrote this, we actually know. We know what you are returning. We know which tables you are querying. So we can be clever about this. So it's what we tell people. If you want to have relations and you cannot use embedded or type adapters, you probably want to use POJOs for your relations, which means you don't have any hidden costs. You only fetch what you need, and it's still observable, and you don't need to do anything for that. But of course, we said SQLite is relational and it supports foreign keys. Room supports foreign keys as well. So inside your entity, you can say this entity has a foreign key to this other entity where I want to match the ID column in that entity with this child column. SQLite foreign keys also support, like, you may have multiple fields matching multiple fields in the other tables. It's very complex. You should just go ahead and read. But once you declare this, now SQLite knows about this relationship. And if it knows, you can say things like, you know what, if someone tries to delete that user, don't let them delete because I have a feed for them. Or you can say, if that user is updated, please update me as well. So we're trying to embrace SQLite rather than trying to hide these details and like create a bunch of pitfalls. Indexes is another great thing. Now the SQLite keeps the data on the disk in a structured way so that you can query it back. So you're going to write a query like this where you want to select feed items which has a certain title. But if you just write this query and don't do anything else, that means SQLite needs to go through every single row in the database to find the ones that are matching. Now, if you're not making this query frequently, that's fine. But if this is the query that you run frequently, you probably want to index it. It's very simple in Room. You just, inside the entity annotation, you can say, well, can you please index this column? If your query is like this, where you have, like, you query title and subtitle together, you can also create a composite index, which means these two things will be indexed together. So if you are querying together, that will be fast. And you can have multiple indices. Like, it doesn't matter. By the way, like, just because you are querying something doesn't mean you should index it, because every index you add has a cost on every insertion or data change. So you need to just measure and see what's the best way. And SQLite's documentation on Query Planner is amazing. Like, if you read that, you will know how to write queries and how to optimize it. Now, testing. We know in the past we haven't been very good in this area, but when we were designing architecture components, testing was a very, very important topic for us. We wanted to have whatever we create for architecture components that can scale and that can be testable. So let's look at how you can test your queries. By the way, you should really test. Just because we are verifying your SQL queries doesn't mean that that's what you really intended, right? Your Java code compiles, but you still test it. Similarly, if your Room SQL compiles, you should still test it. But testing Room is actually very easy. Now, we still recommend testing on the device, but there is no activity or UI, so they run faster. You can also test on the JVM by changing the SQLite bindings we use. So say I'm just going through a sample case. So before each test is created, I create my database, but I create an in-memory database, which means the database will be created when the test starts, and I can clean it afterwards. You want these tests to run isolated from other tests. So you don't want to save the data into disk. So I say after, just close the database so the memory can be released fast. And I can write it as the rest. This is just like I create an item, I insert it to Room, and then make some queries on it, and then verify that that's what I expect. But the way Room is designed actually helps with the overall application testing. Do you remember we talked about those DAO classes we generate? Because you defined how you access the database as an interface, which has nothing to do with SQL, you can very, very easily mock it. So if you have a view model that you want to test, first of all, you can test view models on your computer. You don't need to run them on the device. You can create a mock of that DAO. You can just use Mockito to mock it. And then you can write a test like this, like when load feed with this parameter is called, return these feeds. Because it's just a Java interface, like there is not even any mention of database there. So it's all very well abstracted without you doing anything. Now, migrations is another important topic, right? So as you use the application over time, your entities will change. Let's say if you had this user object, now we start to show user photos, so you wanted to add this new field into that. If you do that, when you run the application, as soon as Room, like you first access the database, Room will say, oops, looks like you changed the schema, but you didn't increase the version. It's going to crash your application. Now you need to handle this. You can simply increase your database version in the annotation, which means you don't want any of the previous data, you want to start from scratch. Or you can write a migration. Now to write the migrations in our database builder, you can just pass a couple of migration implementations. Like this one says, I know how to migrate from 1 to 2. You can have 1 from 2 to 3, 3 to 4, and then Room will run whatever necessary from the current version on the device to your latest version. It will just chain them. And if anything in the middle is missing, then it's going to recreate the database. Another important thing, though, in these migrations, don't use any constants. Always use full SQLite, because over time your application will change, those constants may change, and you will get bugs. OK, we wrote this, but like we said, testing is important, right? So Room also comes with a testing Maven artifact. Like we have a separate artifact so that you can test your migrations. Now, this is a couple of steps. First, when we compile Room, we can actually ask Room to export the schema, this how your database looks, into some JSON files, which you should be committing to your version control system. Pass argument. And then we want these schema files to be visible to our tests, right? So that we can access them. Last but not least, for our Android test, we add this new dependency from Room, which includes some helper classes that will help us with our migration testing. So let's say we are trying to test a migration from version 1 to 3. There is this migration test helper class, which comes from that artifact. We create an instance of that helper. This canonical name is how Room exports these files by default. Just need to think about it much. And we create an open helper factory. Once we have that, we say, OK, migrate from 1 to 3. We ask helper to create the database at version 1. Like, you may even have entities that doesn't exist anymore. It doesn't matter, because it did export the schema previously. By reading that, it can recreate your database in that version. You can just change it directly. You can do whatever you want. By the way, as you realize, this doesn't return you a DAO. It just returns your database instance, because DAO may not be valid anymore. You can just say, run these migrations and validate the schema. Then we give it a database name. We give it the version we want. Now, you may have tables that you had before, and maybe you want to still keep them, but don't tell Room about it. So you can decide whether we should check for these or not. And then you give a list of migrations. So these are the old migrations we have. What will Room do is migrate the database from the previous version to the new version, and then check the schema for you. And then you can also have, like, if you have custom things, how change the entities in the previous versions to the new versions, then you can manually assert on these things. OK, so that was Room. We have a very detailed documentation page on the web page. By the way, like we do for Room, also for all our architecture components, we have a testing artifact, which includes one rule for JUnit and one rule for your instrumentation test that helps with dealing with the background threads we use. So we want to make sure everything we have here is testable, and if it is not, we will fix it. So what's next for you? Room is available today. Please go check it, like play with it, see how it looks. Check out developerandroid.com/arch, which is the main page for all of these architecture components. Now we said these can work independently, but these also work very well together, as you've seen in the live data example Kirill had. So check it out. And also check out the code labs. We have code labs for both Room and Lifecycles, and they're available in the code lab tent. Thank you.